Okay, year 11, so now we're going to go through your paper 2. First of all, finding the reciprocal of 0.8. You know that finding a reciprocal is just flipping the number. So because this is a calculator paper, you can write it like this, and you can do this with your calculator. 1 over 0.8 is going to give you 5 over 4, or if you want to put it as a decimal, it's going to be a 1.25. Another way that you could think about this is that 0.8 is actually 8 over 10. So you could also think about the reciprocal as flipping that fraction. So that's going to be 10 over 8 for the reciprocal. And then obviously you can simplify, again, getting your 5 over 4 or as a decimal at 1.25. Next thing you have to do is some calculator work. So for this, we're going to have the square root first. But because we've got a fraction, I believe that it is best to put the fraction already. So now when we put the square root, we've got the root on the numerator, and then we're going to have space on the denominator. So then there's going to be a 7.4 minus a 2.5 squared. You can do your squared from the square button already, or you can just times it by itself. And then on the denominator, 5.6 plus 7.2. We need to write every figure in our calculator display, so we're going to write that 0.08377972887. If your calculator shows less figures, it's fine, you just write exactly what your calculator is showing. Right, so next we've got a box that has only red, green and yellow beads and pink beads, The table shows the probability that when a bead is taken at random from the box, the color of the bead is red or green. The probability of being red is 0.16. The probability of being green, is 0.2. The number of yellow beads is the same as the number of pink beads. So that means that these two probabilities are going to be the same if I call them x to both of them. What I know is that all probabilities should add up to 1. So it's 0.16 plus 0.2 plus 2 lots of x is going to be equals to 1. So this is going to be a 0.36 plus 2x equals 1. So 2x is going to be 1 minus 0.36, which is 0.64. And then I'm going to divide that by 2. And that gives me 0.32. So the probability that Vera will take a pink bead is going to be a 0.32. You could give this as a decimal. You could give this as a fraction. 8 over 25. But you can't give this as a percentage, 32%, because you're asked for the probability. Next, you know that Kathy is going to take a bead from the box. She will record the color of the bead and put the bead back in the box. And she will do this 50 times. Work out an estimate for the number of times she would take a red bead. So if you know that you will have 50 trials, and you know that the probability of a red for each one of those is 0.16, all we need to do is times these two numbers. 0.16 times the 50 trials is going to give me 8. So 8 times is what she expects to get a red. Next, for question 3, we've got our scatter graph. So this is the information about the number of cups of tea sold by a cafe each day and the temperature at noon that day. So this is the scatter graph. We've got the temperature on the x-axis and the number of cups sold on the y-axis. It says that on a different day, 46 cups of tea were sold and the temperature was 22 degrees Celsius. So I need to show this information on my scatter graph, and for that I will need a pencil and a ruler. So with my pencil, I'm going to show that 22. Again, as we said in paper 1, it's really important that we check the scale, Between 20 and 30, there are 10 little squares, so each one is 1. So that's 22 over there. And 46 for the cups of tea. Again, this time from 40 to 60, there are 10. So this is going to be 50 halfway through. 5 small squares for 10 units. Each one is a 2. So for 46 is 42, 44, 46 up here. That is the point that we need to show in our scatter graph. Then you need to say what type of correlation is that scatter graph show. Now, as the temperature is increasing, the number of cups of tea sold is decreasing. So this is a negative correlation, or just negative. You could say negative and you would get the mark. Now, on Tuesday, the temperature at noon is expected to be 10 degrees Celsius. So using the scatter graph, you need to find an estimate for the number of cups that is expected, that this cafe is expected to sell. So what I'm going to do, again with my pencil and my ruler, I'm going to do my line of best fit. I want to try to be closer to all of these points, and I want to try to leave roughly the same amount one side of the scatter, one side of the line of best fit and the other side. So something like this. I think I'm leaving 1, 2, 3 on one side, 1, 2, 3, 4 on the other side, and I'm going through some of them, but that's fine. So then going up from 10 with my ruler, I notice that my line of best fit will estimate the number of cups sold being 80. So that's what I'm going to write, 80 cups sold. Anything around 76 to 84 would give you a mark. Depends on your line of best fit, but always try to do the line of best fit like we mentioned earlier. So next you've got a rectangle. You know these measurements are in centimeters, and you know that the perimeter of the rectangle is 38. So you know that perimeter is about adding all lengths or all sides, right? And I know that this is a rectangle, so this up here is going to be x plus 4, and this on the right is going to be 3x minus 12 as well. So for the perimeter, I'm just going to add all of them together. X plus 4 plus another x plus 4 plus 3x minus 12 plus another 3x minus 12 is going to be 38. I need to collect like terms here, so that's going to be 2, 8x, and this is going to be plus 8 minus 24, which is going to be a minus 16, and that's going to be equals to 38. So now I'm going to add 16 on both sides, which is 54, and divide by 8 to get x, which is 6.75. But this is not what I need. I need the length of AD, so I need to look here what AD is. AD is 3x minus 12. So because this is the value of x, I'm going to go to AD and I'm going to substitute. That's going to be a 6.75, and then I'm going to take away 12. So 6.75 times by 3 and then take away 12 gives me an answer of 8.25, and that should be, 8.25 for the final answer. Jamal says, if I double the value of x, then the perimeter of the rectangle will double. Is Jamal correct? Now, if I think about the formula that I got for my perimeter, if I think about every value of x being doubled, I still need, in order for this number to be double, I still need these numbers to be doubled as well. Now, you could have also doubled the value of x, find out the perimeter and check that it's not double of 38, and then answer that no. Another reason that you can say is like we mentioned before, is that this constant terms would have to be doubled as well. The constant terms should be doubled too. And that would give you the mark. Answering no only, it would not give you the mark. You need to give the reason. Right, next we have the equation of 5 straight lines. Each of these straight lines is parallel to the x-axis, or is parallel to the y-axis, or has a positive gradient, or has a negative gradient. So if I think about this, the x-axis and the y-axis, if I'm parallel to the x-axis, that means that my line is running this way, so it's a horizontal line. If my line is parallel to the y-axis, my line is vertical like this. If my line has a positive gradient, then my line is going to go uphill like this. And if my line has a negative gradient, it's going to go downhill like that. Therefore, each one of these lines will only fit in one of these columns. So each line should only tick one box. So y equals 3 could be something like this, an equation of a horizontal line, which means that this line is going to be parallel to the x-axis and nothing more. Then y equals 3x plus 2 is a line that has a positive gradient, could be something like this, with a 2 as my y-intercept. The positive gradient means that this line has a positive gradient. Something like this, 3y equals x plus 2. Now we know that for getting the gradient I need y as my subject, but even if I divide everything by 3, my gradient would be 1/3, but it would be still a positive 1/3, so still is a positive gradient. X equals 3 is a line which is vertical, we know this, so it's parallel to the y-axis. And then this one, again, if we rearrange to get the y as my subject, I need to take away x and then obviously divide by 3. So it's going to be 1/3 x plus 2/3, and that would be a negative gradient for this last line. Right, question 6 gives me a rectangle. It says that E is the point on AD such that AE to ED is on the ratio 4:3. So this would have 4 equal parts for every 3 that this one has. Work out the area of the rectangle. Now the first thing that I can notice is that this triangle up here, ABE, is a right angled triangle, and therefore I can use Pythagoras to work out AE. So I know that AE squared, because it's one of the short sides, plus 15 squared gives me 17 squared. So I know that AE squared is going to be 17 squared minus 15 squared. I'm going to do that with my calculator, but also I'm going to square root to find AE. So I'm just going to put this in my calculator in one go, but you could do it in 2 steps if you prefer. So 17 squared minus 15 squared. The important part is that you do the minus because you're finding a short side. That is going to be 8. So I know this is 8. Now, if this AE to ED was in the ratio 4:3, and this side I know is 8, that means that I've times by 2 this 4, which means that I need to times by 2 the 3 as well. Sorry, by 2, giving me a 6, which means that this was 8 centimeters. This is going to be 6 centimeters. Overall, the length of this, the height of this rectangle is going to be 8 plus 6, which is 14 centimeters. And therefore, the area of the rectangle, which is what I'm trying to find, the area of the rectangle ABCD is going to be 14 times 15, which is 210. And my units are going to be centimeters squared, or I can just put it in the answer line. Right, so moving on to question 7. I've got the mass of a half pint of milk is 303 grams. I've got that 1 pint is 0.568 liters. And I've got that 1000 centimeters cubed is 1 liter. So I need to work out the density of the milk. I know from my formula that density equals mass over volume. But the one thing I need to be really, really careful when doing these questions are the units. I'm going to give my density as mass over volume, but I need this mass to be in grams, and I need this volume to be in centimeters cubed. Okay? So I know that the mass of a half pint is 303 grams. So what I can do is I can figure out what the mass of 1 pint is going to be, which is going to be obviously double than that, so 606 grams. And I could figure out in centimeters cubed how much is 1 pint going to be. So 1 pint is 0.568 liters, and because 1 liter is 1000 centimeters cubed, I know that 0.568 liters is going to be divide this, or to go from 1 to 1000, I'm timesing by 1000, so I need to times by 1000 here, which means I'm going to move my decimal point 3 places, 568 centimeters cubed. Now this is the mass of 1 pint, and this is the volume of 1 pint in grams and in centimeters cubed. So that's what I'm going to write over here in grams per centimeter cubed. Now with your density questions, you want to give your answers to typically 3 significant figures. Even if the question is not specifying safely, we can do, so this is going to be 1.06 and then a 6 recurring, so 3 significant figures would round to 1.07. Again, my unit would be grams per centimeter cubed, or I can go down here and write my answer in the number line. Great. So question 8 says that Selena invests £2,000 in a saving account for 3 years, and the account pays compound interest at a rate of 2.5% per annum, so each year. Calculate the total amount of interest, only the interest that Selena will get at the end of these 3 years. Now we know the formula that says that the final investment at the end of those 3 years is going to be that 2,000 times by the multiplier to the power of 3. How do I get this multiplier? Well, I started with 100% and I'm adding a 2.5%. So that's going to be 102.5%, which if I divide by 100 gives me a 1.025. So that's going to be my multiplier. This is going to be the formula that I'm going to put here. 2,000 times by 1.025 to the power of 3 years. This is going to give me 2,153.78. Let's round that to 2 decimal places because we're talking about money here. This is the price of the investment, the £2,000 that she started with plus the interest. So if I just want to get the interest, all I need to do from here is take this value and subtract what she initially invested. So obviously this is going to give me the 153.78 pounds that she got extra. The interest is just what she got extra apart from her £2,000, from her initial £2,000. Next, we have a right angle triangle, actually 2 right angle triangles. One is smaller here, ACD, and one is bigger, ACB. I know that CDB is a straight line, and I need to calculate the length of DB. Now, because these are right angles and because angles are involved, I know that some kind of trigonometry is going to be involved here, SOHCAHTOA. So I'm going to focus first on triangle ACD. I know that this angle is 90, and I know that this is 30, and that this angle is 23. Now the side that connects from one triangle to the other one is this hypotenuse for this right angle triangle. So in this case, from A to D. So I'm going to think about this hypotenuse here. Wait, is this? The best way? If I'm finding the hypotenuse, am I then going to be able? No, because I don't know any of these angles. So then maybe let's find CD, because then I want to use the big side here to get as well this base. Yeah, I think that's going to be best. Let's find CD. So rather than doing that, I'm doing opposite here, opposite over adjacent. So I know that from SOHCAHTOA, opposite and adjacent make tangent. So that means tangent of my angle, which is 23, is opposite, which I don't know. It's CD over my adjacent, which is 30. So 30 times tangent of 23 is my CD. 30 times tangent of 23. It's a 12.73424449, and it obviously continues infinitely many decimals after decimal point. We're trying not to round beforehand. Even though I need to give my final answer to 2 decimal places, I'm not going to round too early. Now, the next triangle I'm going to think about, because that was the other right angle triangle that I have to use, is CAB. Now, this time, the height is the same, but the angle here is just the 23 plus the 12. So it's going to be actually 35. So then I know again that opposite and adjacent is TOA. So tangent of 35 this time is going to be CB over 30. So now 30 times tangent of 35 is going to be my length CB, the long side here. So 30 times tangent of 35. That gives me 21.00622, blah, blah, blah. And then because I'm trying to find the length of DB, all I need to do is from the long one, just subtract CD. So let's write that out. DB is going to be CB minus CD. So that 21.006222 minus 12.73424 and so on. Is going to give me 8.27198, but then I need to round it to 2 decimal places. So 8.27, after the 7 there's a 1, so it stays as a 7. 8.27 meters is my final answer. So moving on to question 10. This shop is selling 17 different types of sandwich, 15 different types of drink, 26 different types of snacks, and 14 different types of dessert. A meal deal consists of either a sandwich, a drink, and a snack, or a sandwich, a drink, and a dessert. So I'm going to think about first about the options for sandwich, drink, and snack. Now, if I've got 17 different types of sandwiches, for each one of those I have 15 types of drink. And for each one of those, I have 26 different types of snacks. So I'm going to do my product rule for counting. And that's going to give me 6,630 possible meal deals with the first type. But then, secondly, I could do sandwich, drink, and dessert. And for that, I've got 17 again, 15 again, but this time 14 times of dessert. So 17 times 15 times 14 this time. 3,570. Overall, the total is going to be adding these two numbers. So the 3,570 plus the 6,630 10,200. So show that there are over 10,000 different ways. Therefore, there are over 10,000 different ways of choosing a meal deal. Now, the owner of the shop says, if I halve the number of snacks available, this will halve the number of ways to choose a meal deal. The owner of the shop is incorrect. And we need to explain why. So if we halve the number of snacks and we make this into a 13, we're still leaving the same amount of options for the second way of making a deal. So that would mean that I won't halve the total number, I would just halve one of them, but if the other one is not being halved, the total will not be halved. So he should also halve the number of desserts for the total to be halved. Right? Okay, so next we need to expand and simplify our triple bracket. You know that you can start with the first two and then times by the last one. You can start by the last two and then times by the first one, or you can times the first and the last and then multiply by the middle one. Let's start with the first two. That's the way I normally do it. Starting here, that's going to be a 3x squared minus x plus 6x minus 2. This whole thing will be then times by x plus 4. So to make my life easier, I'm going to collect the like terms first. So I'm going to get a 3x squared plus a 5x minus 2. That's going to be times by x plus 4. So now I'm going to do my expanding double bracket. 3x squared times x is a 3x cubed. 3x squared times 4 is a 12x squared. 5x squared times x is a 5x squared. Sorry, 5x times x is a 5x squared. 5x plus times 4 is a 20x. Minus 2 times x is a minus 2x. Minus 2 times 4 is a minus 8. Collecting like terms here gives me 3x squared plus 17x squared. Sorry, 3x cubed from here. 17x squared from here. Plus 18x from there, and the minus 8 at the end. Next, I need to solve an equation. I've got a denominator on this side, so I know that this denominator, because it's applying to all of the numerator here, I'm going to times by 4 first to get rid of this. So 23 minus 2y is going to be equals to 4 times everything here, so 4y minus 28. Or if you write it with brackets, then you expand your bracket. I just skipped one step there. And then we're going to collect y's on one side and numbers on the other side. So I'm going to plus the 2y to give me 6y. And I'm going to plus the 28 to give me 51. So then 51 divided by 6, you could leave this as a 17 over 2. Or you can put it as 8.5, because this is a terminating decimal, so it's okay. Or you can leave it as a fraction. Last, I need to solve this quadratic equals to 0, and I need to give my solutions correct to 3 significant figures. So this already gives me the hint that I'm going to have to use my quadratic formula. So I need to figure out what A, B, and C are going to be. A is 3. B is minus 3, because I need to include the sign. And C is going to be minus 7, because this is already equal to 0. So I don't need to rearrange anything. Now my quadratic formula is my b squared minus square root of, minus b plus or minus the square root of b squared minus 4ac over 2a. And now I'm going to substitute my numbers, being really careful with the negatives, especially with the negatives on B. If I've got a minus B, it's a minus 3, plus or minus the square root of brackets, because it's the whole minus 3 that is being squared, minus 4 times by A, which is 3, times by C, which is a minus 7, all of that over 2 times 3. Now, when I'm going to do it in my calculator, again, I could put the fraction first. I could do the minus 3, or I can already see that this is going to give me just a positive 3. And because I don't have a plus minus button in my calculator, we know that we do it first with a plus square root of minus 3 squared brackets. Don't forget about the brackets. Minus 4 times 3 times a minus 7 over 2 times 3, which is 6. I could write it as a 6 already. Now this is going to give me my answer in exact form, but because I need to give it to 3 significant figures, the first answer, that I give is my 2.1. Now this would be my third significant figure, that's 0, but it's going to become a 1 because after that there's a 7. Or now I'm going to go back to my answer. I don't want to delete anything because now all I need to do is change this for a minus, and that's going to give me my other solution, which to 3 significant figures is going to be minus 1.1. And again, this third significant figure is going to go up to a 1. Right. Next, I've got a region. I need to write down the inequalities that define the shaded region. This is the region I'm looking at. So now I'm going to think about what equations this line have, and then I'm going to think about how do I transform that into inequalities. So first of all, this one is the easiest one. Because it is a horizontal line, it's going to be y equals, and because it's going through minus 2, it's going to be equals y equals minus 2. Now, this other line here, we know that any straight line is going to have an equation y equals mx plus c, where m is my gradient, c is my y-intercept. For this line, the gradient is going to be, well, I pick 2 points, and I see that I'm going up by 2 units every 2 units that I'm going across. And obviously, don't just count squares, focus on the units and the scale in your axis. So 2 every 2, 2 divided by 2 is 1. So y equals x plus the y-intercept, which in this case is 1. Now this other line looks, is going down, so that means it's going to have a negative gradient. Now how am I going to choose that gradient? Well, any of these points that I pick is not going to be really useful because it's not in a corner of any point. So I'm going to pick the 2 that I definitely see nice and easy, which are the x and the y-intercept. Now for every 5 that this is moving down is going 4 across. So the gradient of this line is going to be minus 5 for my change in y over 4 for my change in x. And then that's going to be x and obviously plus 5 as my y-intercept. You could leave it like this, or you could times everything by 4 if you prefer to get your 4y equals minus 5x plus 20. There's no need to do this. You could leave this with this inequality, with this equation, and then convert it to the inequality. Now, thinking about the region is above the line y equals 2, so that means that every y value here is greater than. I could pick a point. Let's pick a point here. 1, 1 is in my region. I know that 1 is bigger than minus 2. So y has to be bigger than minus 2. Let's check for this line what's happening here. If my point is 1, 1, when I substitute in here 1 for y and 1 for x, I can see that this side is a 2, so this side is bigger. So that means that my y is going to be less than or equals to x plus 1. The reason for the line in here is because the line is solid and is not dashed. So I should also write that there. And last but not least, thinking about my 1, 1, let's use this one. If I think about this 1 and then 5 minus, this is going to be a minus 5 quarters times 1. So 5 minus 5 quarters gives me 15 quarters, which is a 3.75. So I can see already that this is bigger. So the y is going to be less than or equals to, again, minus 5 over 4x plus 5. Choosing a point and comparing your expressions is always useful to realize which side your inequality should be pointing to. But always writing the equations first is normally easier, and then thinking about what inequality that would be. Natalie is asked to shade the region y is greater than or equals to x on a coordinate grid. And here is her answer. So what error has Natalie made? Now, many people thought that she had shaded the wrong region because I maybe that might be linked to the fact that when we saw it in class, we said to shade the wrong region and label the correct one. But actually, if she shaded the correct one, that's absolutely fine. The mistake that she made is that when you have an inequality like this, the line that you actually have to draw is y equals x. Y equals x is a line that has a positive gradient of 1 and a y-intercept of 0. So the line that she should have made is actually this one. And that's the mistake that she made when drawing this. And then she should have picked the correct one. So y greater than x would be this one. And she could have shaded the correct one anyway. No need to label if she shades the correct one. So she drew the wrong line. Okay, so moving on to question 13, thinking about now ratios, but this time between solids. So I'm thinking about a ratio for volumes, a ratio for areas, but then I'm also thinking about a ratio for lengths. So if I know that for volumes, the ratio of A to B is 27 to 1,000, because I want to compare surface areas, I want to find the surface area of solid B, knowing the surface area of solid A, I need to know what is the ratio for surfaces. But to get the ratio for surfaces, I definitely need to go for the ratio for lengths. And that would be, because the volume is cubic, if my length is k, my surface is going to be k squared, and my volume is going to be k cubed. So that means I need to cube root this 27. Cube root of 27 is going to be 3. And cube root of 1,000 is going to be 10. You could also check it with your calculator. So now, to get the ratio of the surface areas, I need to square these numbers. So that's going to be 9 to 100. Now I can see that for surface area, if my ratio of A to B is 9 to 1,000, sorry, not 1,000, 100, and the volume, the surface area of solid A is 810. How am I going here? Well, obviously, from 9 to 81, I'm timesing by 9. So add an extra 0, timesing by 90. Times by 90 on this other side. And that gives me 9,000 centimeters squared for the surface area of B. Next, we've got some vectors. A, B, C, D is a parallelogram. I know that A, B is called vector P, so going in this direction is called P. A to D, so going in this direction is called Q. The point E lies on AC such that AE to EC is 4 to 1. So for every one part in here, I've got 4 in there. So that means that this would be 4/5 of the full vector, and this would be 1/5 of the full vector. So now I need to find DE in terms of P and Q. To find DE, I'm going to just add it to my diagram first to understand where am I looking for. From D to E in this direction. With vectors, it's really important that we focus on the direction. So now what I'm going to do is I'm going to create a path. I'm going to create a path to go from D to E using vectors that I know. So I'm going to go from D to A, and then I'm going to go from A to E. And then I'm going to focus on how can I figure out these vectors. First of all, D to A is just reversing the direction. So it's going to be a minus Q. But then A to E, I need to think about this for a second. A to E is going on this direction. But I know it's going to be 4/5 of the total. Now, 4/5 of the total, which following this direction, the total is A to C. How do I get A to C though? How do I get A to C? Well, I can go from A to B and from B to C. A to B is actually easy. It's already given as P. B to C, however, I don't know it, but I can figure out that this is a parallelogram. So that's definitely going to be the same as that one. So it's definitely going to be Q. They are parallel and they are the same length, so they must be the same vector. So P plus Q is this, but now I've got to get 4/5 of that. So then all I need to do is expand here and collect my like terms. 4/5 B plus 4/5 Q. The 4/5 B stays like this, and then the minus Q is actually going to be minus 5/5, which if I then add 4/5, I'm going to have a minus 1/5 Q. You could leave it like this as the simplest form. You could also, if you wanted, factor out a fifth and give it as a 4P minus Q. And that would be perfectly fine, any of these answers that you get. So let's write one of those in here, in the answer line. So moving on to question 15. We've got a speed time graph, okay? I need to calculate an estimate of the gradient of this graph at time 50 seconds. So I'm going to find my 50 over here. I'm going to go up to my graph over there, and I'm going to find the gradient. What do I mean by the gradient? Is the line that is tangent here, and I'm going to do, after I've drawn this line, I'm going to try and figure out what the gradient of this line is. Now this point apparently is a nice one, and then let's use this one, because then the change in x is going to be nice and easy, 30. And the change in y here, I can see it goes from 0 to, well, this is going by 0.2s, because 5 little squares makes it 2. So then this is going to be 3.8. So that means that the gradient of this line is my change in y over my change in x. So a 3.8 over 30. So that's 3.8, that's 30. Meaning I get an answer of 0.126 recurring. Now, anything between 0.1 and 0.15 would be acceptable. It obviously depends on your tangent, which has to be really close to both sides, okay? If you do your tangent, one has to go through the point, but also it needs to be roughly the same angle from both sides. It can't be really close to one side and then go really far away from the other one, because then that wouldn't be the closest tangent that you can draw. And then describing what your answer to part A represents. Whenever we have a speed time graph, we know that this line represents the acceleration, because in any graph really the gradient represents the rate of change, and we know that the rate of change in speed is acceleration. So if you said acceleration, that would be straight a mark. Otherwise, you could have said the rate of change in speed. But actually, if I think about the tangent, it would be the instantaneous rate of change in speed. So this will still give you a mark, but acceleration is the best answer here. Next, we've got a triangle. This is not a right angle triangle, so definitely no Pythagoras, no SOHCAHTOA, but I could definitely use sine rule, cosine rule. Now, in this case, if I look, I've got a matching pair of angle and side, and then I've got to find an angle which is matching to another opposite side. So definitely sine rule. Sine rule to find an angle. I'm going to write this out. Sine x over 8 is going to be sine 130 over 12. And therefore, sine x is going to be 8 times sine 130 over 12. And I'm going to do my sin minus 1, my inverse sin. I'm just writing this out because I am going to put this as a whole in my calculator. So sin minus 1, and then a fraction in here with an 8, sin 130 over 12. And let me close my bracket at the end. So I get an answer of 30.7. 3 significant figures. After the 7, there's a 1. So that 7 stays the same, stays as a 7. 3 significant figures. Always check your how much you need to round it to, because this is an angle, it's in degrees. And there we go. So question 17 gave you a formula for pressure, even in case you didn't remember. Pressure is force over area. So a disc is placed on a horizontal ground. The disc, when I think about a disc, is a circular disc. Exerts a force F newtons over an area of A centimeters. F is 576.2, correct to 1 decimal place. And A is equal to 72, correct to 2 significant figures. Now, when I know that my values have been given with a range, with a rounding error, I need to make sure to write the error interval for that. And in this case, if I think about 1 decimal place, that 576.2, the previous value and the next one is going to be 576.1 and 576.3. So halfway between is where my value could be, because these values are going to round up here, these values are going to round down here, and this one is going to round up as well, but we're not going to include it in our interval. So that's going to be a 576.15 and a 576.25. Then your A is correct to 2 significant figures. So that means that if I again do my number line like this, the previous one to 2 significant figures would be 71, and the next one would be 73. So halfway between is where my number is going to be. So that's going to be 71.5 and 72.5. Now, the pressure here is force over area. So what I want to do is, by considering bounds, calculate the value of P to a suitable degree of accuracy. We're going to see loads more about this after Christmas, but for now, we know how to calculate bounds already. What do I mean by bounds is what is the lowest that P could be and what is the highest, so the upper bound for P. Now, if I want P to be as small as possible, my F has to be as small as possible. And my A has to be as big as possible. So it has to be 72.5. So the lower bound for P is then going to be divided by 72.5, 7.946896. Let's write many decimal places now and you'll understand why in a moment. So for the upper bound of P of the pressure, if I want this to be as big as possible, I want F to be as big as possible, so 576.25. But I want my denominator to be as small as possible, because that's going to make my answer bigger. So 71.5. So that means that the upper bound, 576.25 divided by 71.5, is now 8.0594405, and that is recurring, but it doesn't matter. We can say that they go up. Now, we've got a lower bound, we've got an upper bound. But I want to figure out just one single value for P to a suitable degree of accuracy. Now, what that value of P would be is the value that both of them round to. So if I think about this, say to one decimal place, this would be rounded to 8.1, and this would be rounded to 7. Well, this 9 is going to stay the same, so 7.9. So they are not equal. That means that to one decimal place is not good enough. But if I think about rounding it to the nearest whole number, this would be rounded to 8. And this 7.9 is also going to be rounded to 8. So the pressure would be 8 because both, because I need to give a reason for my answer, both the lower and the upper bound round to 8. Yeah? So then P will be 8. Now this one was a bit tricky because it wasn't a normal completing the square like we usually do it by factoring out the 4 and then having that coefficient on the outside and having x for completing my square. Now in this case I had to do ax plus b squared plus c. So the coefficient had to be inside, and that's what made it a bit trickier. If I am getting 4x squared, that means that when I'm squaring this expression here, the a is being squared and the x is being squared. So definitely I'm going to have something like a 2x inside there. But I also know that when I expand this, if I expand this double bracket ax plus b times another ax plus b, that's going to be, like we said, a a squared times x squared. Then I would have a times b times x plus another a bx plus then another b squared. So overall here with x, I have 2ab. Now if my a is being 2 already, 2 times 2 times b should give me 12. So 2 times 2 already gives me 4 times 3 is going to give me 12. So I'm going to write this, and I know that this is actually going to give me, like we said, 4x squared plus 12x plus b squared, which is 9. But I actually want to have this as a 7, so therefore I'm just going to take away 2. So taking away 2 would give me the complete expression. Next we had some recurrence relation. This says that at the start of day n, the number of cells being used in an experiment is t sub n. So at day 1, t1, day 2, t2, day 3, t3, and so on. At the start of the next day, the number of cells being used in the experiment is tn plus 1, and the way of calculating tn plus 1 is doing k times tn, where k is a positive constant. What do I mean by this? Every day, I need to take the number of cells on the previous day and times it by k. So if T1 is 250,000 and T3 is 490,000, what I'm going to do is I'm going to link T1 with T3 going through T2 in the middle. So I know that T1 is this. That means that T2 has to be K times the previous one. So T3 is going to be K times the previous one, which is K times this. So that means that this is K squared times by 250,000. But I know already that T3 is 490,000. So if that is K squared, then all I need to do is divide. And that would give me K squared. Square root, obviously these zeros will cancel out. Square root, and that would give me that K equals 7/5, or whatever that is as a decimal. You can work it out with your calculator. 1.4, okay? Or K equals 1.4. Now, T7 to T4 is m to 1, and I need to work out the value of m, giving my answer correct to 3 significant figures. So what I'm going to do next is I'm going to figure out, well, I know now the formula is going to be for T7, or let's do T4. I know that T4 is going to be K. Now I know that K equals 1.4 times the previous one. Remember that the previous one was T3, which I know was 490,000. That's going to give me 686,000. T5 is going to be times by 1.4 again. So T5 is going to be 960,400 times by 1.4 again to find T6. And then times by 1.4 again to find T7. 1882384. Right? So then, working out the ratio of these two, I've got these two numbers, and I want to make this as an m to 1. So I'm going to divide by the 686,000. So I'm going to take this and I'm going to divide it by 686,000, which is going to give me 2.744. Round it to 3 significant figures, 2.74, because the 4 stays the same. Right. Finally, we've got a question with a frequency table. Donna found information about the areas in meters squared of some fields. The table shows some information about her results. Donna drew a histogram of her results. Now, if the question is not asking me to draw the histogram, but it might be worth just still think about what this histogram would look like. So I'm going to have from 0 to 10,000. I'm going to have a certain height. Remember that in my vertical axis goes the frequency density. Now, I know that the class width for this one is at 10,000. So the frequency density is going to be 4 over 10,000, which is 4 times 10 to the power of negative 4. So obviously that's going to be 0.0004. 1, 2, 3, 4. Yep. So that's going to be the height of one of my bars. Then I'm going from 10,000 to 30,000. Again, now this is 20,000 gap. So the class width is 20,000. So the frequency density is 16 over 20,000, which is 8 times 10 to the power of minus 4. So double than that, 0.0008. that's going to be the height of the second bar, and so on. At least starting that histogram gives me an idea of what's going on with these numbers. Now, it says here that the height of the bar for the class interval from 70,000 to 110,000 is twice the height of the bar for the class interval from 0 to 10,000. Now, if I know that my height for the first class interval, height of the first bar is a 0.0004. Actually, not just the height, is actually the frequency density, which is giving me the height. I know that the frequency density or the height of the, what is this, the fourth bar is therefore going to be 0.0008, because that's the frequency density. Now, what I need to write is the frequency for that interval, but I know that the frequency density was frequency over class width. So I know that the frequency is just timesing the frequency density with the class width. Because also I can think about the frequency as the area of this bar. So if the height is a 0.0008, I'm timesing this by the class width. Now the class width between 70,000 and 110,000 is, let's do that, taking away so we don't make any mistakes. Take away 70,000, 40,000, times that by 0.0008, and that gives me an answer of 32. The frequency for that last bar is, not last one, but second to last one, is 32. Now, it says here that the height, the actual height, because obviously this is what the units are for the frequency density, but the height measured in my piece of paper from the class interval 10,000 to 30,000 is 4 centimeters. So I know that this interval here has a frequency density of 0.0008. So the frequency density is that. And I know that the height in real life has to be proportional. So if this is 4 centimeters, the proportion here, we can compare it with the height of the bar for this class interval. Now this class interval has a 30,000 gap, and it has a frequency density, a frequency of 15. So it's going to have a frequency density of 15 over 30,000. I think I put one extra zero. So that's going to be 0.0005. Okay. Now, what is this height going to be? Well, I could obviously go down to 0.0001, dividing by 8. And that would be divided by 8 here, which is going to give me half a centimeter. And then from 0.0001 to 5, I times by 5. Timesing by 5 in here is going to give me 2.5 centimeters, which is going to be my final answer for this one. So whenever you think about a histogram, always, even if the question is not asking you to draw it, always make sure you're drawing the histogram, or you're actually at least drawing a part of it to understand what is going on. And always remembering that the area of each bar is going to be proportional to the frequency. So the height is going to be proportional to the frequency density. So that was it for paper 2. I hope it was useful, and I'll see you soon.